Alright guys, so I'm going to go over one of the practice problems that is already on your PowerPoint for Boyle's Law. This is the first example problem that you guys already did, but I'm just going to go through it with you. If this gets a little shaky, just be patient with me because I'm doing this off my phone. Alright, so the problem. A cylinder has an applied pressure of 4.0 atmospheres and a volume of 6.0 liters. So what is the volume if the applied pressure is decreased to 1.0 atmospheres? Alright, so remember your equation for Boyle's law is P1 V1 equals P2 V2, okay? Because Boyle's law is the relationship between pressure and volume. All right, so just like we've been practicing all year, and what I've been hounding you guys to do all year is to first write out your given, so what you know from the problem. So the original pressure is 4.0 atmospheres, and the original volume is 6.0 liters, okay? And then what else we're given in the problem is the second pressure, so P2 is 1.0 atmospheres, okay? And your unknown, so what the problem is asking for is what is then going to be the volume if 1.0 atmospheres is your pressure, okay? So what we're solving for here is V2. So if we plug all of this in right here, P1, so our first pressure is 4.0 atmospheres times our first volume, which is 6.0 liters, equals our second pressure, which is 1.0 atmospheres, and then we are solving for our second volume, okay? So now to solve for V2, we're just going to do some basic algebra. So 4 times 6, that is 24.0 equals 1.0 times our second volume. So to solve for this, we need to divide 1.0 from both sides to solve for V2. So 24.0 equals our second volume, okay? So now going back, double checking that you have the correct amount of sig figs. In our problem, we have, in this number, there's 2 sig figs, in this number, there's 2, and in this number, there's 2. So we have to decrease this number. Right now, 24.0 has 3 sig figs. So our final answer, our second volume, would be 24 liters. Okay, so that's an example, just step for step, how you would solve the Boyle's law problems.